Okay, hi guys. This is our assignment for Monday, March 30th. So we're just going to run through it real quick. So we have dealing with parallelograms. We have defined our parallelogram as having two pairs of opposite sides that are parallel, and then we have the four properties. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So in number one, you have both sides and angles, so we know our opposite sides are congruent, we know our opposite angles are congruent, and our consecutive angles are supplementary. Okay, so you can use those properties in that one. In number two, we have some additional properties we can use from the past. Vertical angle theorem, we know that vertical angles are congruent. We know that alternate interior angles are congruent when the lines are parallel, and since it's a parallelogram, we have parallel lines. You can then also use the fact that diagonals bisect each other here for number two as well. Okay, so this one you're going to have to use that opposite sides are congruent. You're going to have to use that diagonals bisect each other. You're going to have to use the vertical angle theorem and the alternate interior angle theorem to find your solutions for two. For number three, again, you're going to have opposite sides are congruent. You also are going to want to use the alternate interior angle theorem. And you're also going to want to use, you know, a big angle here. This is going to be 70 plus 42. So this big angle is 112. Right, and then you should be able to use consecutive angles. So 4x plus 112 should be 180. Right, you have two different variables down here. So again, 4, you're going to be using opposite angles are congruent, and consecutive angles are supplementary. For number 5, you're going to use opposite sides are congruent, and you're also going to use the fact that diagonals bisect each other. And for 6, opposite sides are congruent, and you can also use the alternate interior angle theorem on this one. Okay. 7, you're just given sides, so we're going to use the fact that opposite sides are congruent to set up some equations and solve for x and y. And we're going to go, that's the one I do want to go through together here. Okay, so I'm not sure why my marker is not here. Okay, I'm not sure why my pen's not showing up, but I got the one from the annotations here. So opposite sides are congruent, so we can set up two equations here. We can set up 21. It's not what we want. Let's use red and let's make it bigger. So we have 21 equals 3x plus 3y. Okay. And then our other equation is going to be 2x plus 4y equals 6y plus 1/2 x. Okay, so we have a system of linear equations. We have two different equations, which means you want to use substitution or elimination. So we don't, if we were in school and we had the calculators, we could use menu 3-2, but we don't have them, so we're going to do it by hand. So we're going to have to use elimination or substitution. I think substitution here is your easiest bet. Okay, so I'm going to solve for x in the first equation. Again, you can pick x or y from either one of these two equations. I'm going to pick x from this first one up here. So we got to get it by itself first. So I'm going to subtract 3y from both sides. So it's going to be 21 minus 3y equals 3x. All right, we're going to subtract 3y from both sides, and this is what we get. Then to get rid of the 3, we need to divide by 3 on both sides. So we're going to get 21 divided by 3 is 7. 3 divided by 3 is 1, so 7 minus y is going to equal x. Okay. We can then substitute in. Okay. First thing though, I want to get rid of this half, so I'm actually going to multiply this whole thing by 2. Okay, I'm going to multiply the whole thing by 2 to get rid of the 1/2. So we have 4x plus 8y equals 12y plus x. Okay, we can now substitute in 7 minus y for x here and here. We're going to substitute in our 7 minus y. So we really have 4 times 7 minus y plus 8y equals 12y. And we're going to substitute in again here. So instead of x, we're going to put 7 minus y. So plus 7 minus y. All right. And again, you can put that in parentheses, but it doesn't matter because you're just adding it. All right, we distribute here, so we get 28 minus 4y. Then everything else stays the same, so then plus 8y equals, and then we have 12y plus 7 minus y. Right? If we keep this in parentheses here, we just distribute the 1 and we get 7 minus y. We can then combine like terms. So on this side, we have 28. Negative 4y plus 8y is a positive 4y. 12y minus y is 11y plus 7. Okay. We then have to get all the y's on one side and everything else on the other. So first thing I'm going to do is subtract 4y from both sides. Okay, that's going to leave me with 28 equals 11y minus 4y is 7y. And then we have plus 7. Okay, we can then subtract 7 from both sides. That's going to give us 21 equals 7y. Divide both sides by 7, and you're going to get y equals 3. Okay. We want to find x now, so we can now take our 3. We can plug it in here for y. Okay, so we're going to have 7 minus 3 equals x. And that's going to give us 4. So you should get x is 4 and y is 3. Okay, so we set our opposite sides equal to each other because it's a parallelogram. And then we had 2 variables and 2 separate equations, so we used substitution. I solve for x in the first equation. You subtract 3y on both sides, then divide both sides by 3. And you're left with 7 minus y equals x. And then you substitute that into the other equation. Solve for y, plug it back in, and find x. Okay, and then we can substitute that back in to check our answer. So 2 times 4 is 8, plus 4 times 3 is 12, so 8 plus 12 gives us 20. Okay, here, 6 times 3 is 18, 1/2 times 4 is 2, so that's 20, so that's good. And then this one has to be 21, so 3 times 4 is 12, plus 9, it's going to give us 21. So we know we're good. All right, and then last question here, it's going to be very similar. So it says E is the intersection of AC and DB. So you want to draw in an intersection here. Okay. And this is point E in the middle. Okay. AE is 2x. EC is y plus 7. DE is x. And then EB is 31 minus 7y. Okay. And you're going to use the property that diagonals bisect each other to figure out your equations there. And then that's very similar to number 7. So I'm going to leave you to do that one or ask me for help if you need more specific help. But We've given you the properties you're using for 1 through 6. We've done number 7 together. And you should be able to use all that to figure out number 8. So number 8 is very similar to number 7, except instead of using opposite sides or congruent, you're going to use the fact that diagonals bisect each other. Okay, again, please contact me if you need any assistance. We'll do a Google Meet again tomorrow at 7:30. But let me know if you need any help.